I'm a skeptic and he's a skeptic. Show me.
I'm a skeptic too. That's why we're here. This is a question which NASA has ignored for about 12 years. 1976, NASA spent $1 billion of taxpayers' money, went to Mars to search for life. They took these pictures and they basically put them in a drawer. And
pictures that you have with you, is that right?
That we have with us, yes. And they said basically that...
Well, there's some video. We want to take those pictures?
Well, let's take a look
those
here,
first,
all right? This is the object that we're talking about. This is a mile-long object that looks like a human face. When NASA saw this pop up on a frame in '76, it put the pictures quietly away and never looked at them again. What we have done, in lieu of NASA officially doing it, is to set up something called the Mars Project, which is a non-profit research group that's been going on now for 5 years. And we have brought the best computer technology and skills, scientific skills, over a wide range of disciplines to try to figure out if, in fact, this is real, if this is really something that was made by intelligent life. In terms of the data we now have, in terms of the analysis, we have several levels of analysis. Each level, and I wrote at great length in the book about that, each level of the analysis brings us closer to being able to make the decision that, yes, someone did it. But we're not yet at the edge of that cliff yet. We need to go back to Mars. We need to get better pictures, and we know what we're looking for. We know where on that curve we should find things if, in fact, it's artificial, if it's, as I say, real. And if we find those in the new images, then we will know, and then you're going to see, as I said before, history turn a very dramatic page.
This is not just theory. You have brought computerized analysis to bear on these images, and that analysis, you say, bears out your theory.
Well, these are analytical techniques that have been developed at the MIT Artificial Intelligence Lab over about the last decade, Bill.
This is the three-dimensional stuff that we're looking at now.
Three-dimensional recreation. One of the claims has been that this is a trick of light and shadow, and when you look at it from another direction, it would all go away. Well, as your audience can see, we can look at it from 360 degrees all the way around, and it doesn't go away. It is a three-dimensional, heavy-browed, recessed-nosed, extended chin character with great precision in terms of its elements, lying there looking straight up. And whether it's artificial, we will have to go back and look further, but the trend curve of the data is supporting the hypothesis, not detracting from it.
The face is extraordinary. I mean, people who even just saw it as a grainy photograph in the newspapers would have thought immediately it really is human-looking. When you find out it's a mile from its forehead to its chin, I don't know if it makes it more likely or less likely it was made by someone.
I don't think the scale has anything to do with it in terms of if this is real, we're looking at technology, we're looking at high-tech. We're not looking at Martians, Valerie. We're looking at people who may have come from some other star system and visited the solar system and left this for us, meaning whoever would intelligently explore their own solar system someday, to find.
What is the other scientific theory that this could be possible?
Well, that it's wind erosion, that we're looking at geology, we're looking at a weird quirk of nature, you know, a one-time event in the solar system that's produced a remarkable likeness to a human being, that we're looking at psychological projection.
What's your answer to that?
If you look at the details, if you look at the correlations of features, both among this object, within the object, and it in placement to other things we found in the surrounding terrain, the mathematics and geometry begin to impel one away from coincidence and geology and more in the direction of intelligent design.
Like there's teeth inside the mouth and a tear. I mean, this is not just an imagination, oh, that looks like that might be a tear.
And by symmetry. It's very difficult in a geological model to create bisymmetry in nature. And in this one region, not only is the face bisymmetrical, but there are certain other objects within 100 miles, within 10 miles actually, 100 square miles, that are also bisymmetrical.
Do you really, deeply, honestly believe there is intelligent life on Mars? Don't give me a scientist's answer now. What do you think?
It doesn't matter what I believe more.
Oh, sure it does.
No, it doesn't, because we can find out. And the wonderful part of this data is it's within our purview to go back to Mars and find out.
Come on, Richard, yes or no now?
The consequences of finding out more could change the way we live. So it's important that we know, and we can know. That's crucial. We have to know. The hypothesis that I like is that the stuff on Mars, the monuments, if they are monuments, is a remnants of a culture that came from someplace else, from the stars, migrants, visitors, wayfarers that came to the solar system and left us a monument to what we would become, because they knew someday in their science and their understanding that we would develop our own space flight, and we would reach out in curiosity to the rest of the planets of the solar system, and we would find what they had left for us.
In the next few years, this will be confirmed. I mean, we're going to know one way or another because they are going to photograph the heck out of this thing at some point, right?
Both the U.S. and the Soviets now have missions on track to go back. The U.S. Mars Observer mission leaves in 1992. The Russian Mars photography mission, surface rovers, balloon cameras, radar mappers, all of that goes back in the 500th anniversary year of Columbus and the 75th anniversary year of the Bolshevik Revolution. So in 5 years from this afternoon, we should know.
Will you be disappointed if it comes back and they say, you know, you look at it closely and it just isn't there?
Well, let's see. I have a bottle of champagne riding on this in Denver. If you want to, kick in another bottle, I'll be willing to take on the bet.
I tell you, I hate to bet against it because anybody, as far as I'm concerned, should hope, just for the sake of excitement, that it's real. I mean, because it's an exciting event.
The neat thing is, David, this lands right in the middle of the scientific process. It is an interesting theory. We have some tantalizing data, and we can find out. And we're going to find out in 5 years. Okay.
Today we have only a single example of living systems in the universe, right here on Earth. But we are looking for another, on the planet Mars. This year, the United States is sending 2 identical unmanned Viking spacecraft to Mars. Each will land a small scientific laboratory gently onto the Martian surface, with its delicate instruments intact. The first lander is targeted for a spot that appears to be the remains of an ancient Martian river near the equator, where the history of water and its effects might be traced. Viking's initial action is to take pictures of the area around the landing site. Within seconds after touchdown, one of 2 cameras scans a tiny segment of the surface where one of the spacecraft's 3 feet is resting. Then it shoots a panoramic survey of whatever is in view. Man's first close look at the Martian landscape. Both pictures are transmitted up to the mothership, the Viking orbiter, which relays the pictures and also data from its own experiments back to Earth. To analyze the surface of Mars, a scoop at the end of an extendable arm digs into the top few inches. Then deposits the material into the spacecraft soil processors for delivery to the instruments inside. The direct investigation of the Martian surface for evidence of living microorganisms is conducted on the assumption of a carbon-based life, similar to that on Earth. Like other components of the spacecraft, the biology instrument is fully automated and is extremely complex, considering size, weight, and lack of a scientist in attendance. 3 experiments are conducted. One isolates a tiny Martian world within a sealed chamber. It is provided with Martian atmosphere with identifiable carbon-14 molecules and simulated Martian sunlight, but no liquid water or other non-Martian ingredients. If photosynthesis occurs, as on Earth, any living organism in the soil will assimilate radioactive carbon to build its own protoplasm. Heat will release the carbon for detection. An opposite approach searches for organisms that need water and a rich organic diet. Martian soil and a so-called chicken soup solution incubate in a test cell charged with an atmosphere of known gases. If life processes occur, gases are exchanged, some extracted from the surrounding atmosphere and consumed, while others are exhaled. Analyzers monitor the enclosed atmosphere, noting any changes. The third experiment looks for the release of carbon dioxide from a Mars sample moistened and fed a radioactive nutrient. If metabolism occurs, radioactive carbon dioxide gas will be produced, and Geiger counters can identify it. Still another instrument, called a gas chromatograph mass spectrometer, tests the Martian soil for organic molecules. Although not a life detection experiment, its results have important implications to the search for life on Mars. The soil is heated, breaking down complex organic compounds into simpler molecules for identification. Analysis will indicate whether they were related to biological processes or were formed by purely physical means. Finding organic molecules may be related to life, but also would be an extremely important clue to the chemical evolution of the planet. All of Viking's experiments have some bearing on the question of life, but separately and together, they are looking at the total Martian environment: the surface, the interior, and the atmosphere. The inorganic analysis of the surface, by clarifying which chemical elements are present and in what proportions, will tell about the mineralogy and perhaps the weathering processes on Mars. Viking seismometer will record any ground motion or Mars quakes. Large volcanoes have been discovered on Mars, but no one knows if any are active. With 2 landers on the surface hundreds of miles apart, the location as well as the magnitude of any crustal motion or volcanic activity may be plotted accurately. A miniature weather station with needle-like sensors measures the atmospheric pressure, the temperature near the surface, and the speed and direction of the wind. Winds and dust velocities up to 300 miles per hour are possible on Mars. The lander's cameras serve a number of purposes. They can record pictures in color and in stereo, revealing changes that occur in surface features or dust cloud formations. The cameras locate the best spot to trench and obtain soil samples. They are used to inspect little magnets on the soil sampler for the presence of magnetic iron, and to monitor other visible functions and gauges of the lander. With today's knowledge of Mars, many scientists believe that chances are slim that life exists on the planet. They would like to be proved wrong by Viking.